Hello friends, this is my video on ADCs. So uh, for the first time on my channel, I'm showing the video on stimulating software, which is Proteus. This is Proteus, and it simulates your circuits. So it basically eases your work, and you don't have to build your circuit. You don't have to make the connections on breadboard or by whatever you do, like soldering or that kind of stuff. So what it does is it uh, it gives you a freedomness of picking up the components, like this component, this is an 16x2 LCD. So you can pick up the components, make your own circuit, and burn the code in this microcontroller. So I made a project on ADCs, that's analog to digital converter, using an 0804 ADC. That's a 8-bit analog to digital converter, and it can convert only one analog input at a time. So this is what the pinout of 0804 looks like. So it requires a V reference. Basically, it requires the half of the reference voltage. It's just it's an internal configuration, so I don't know why it requires half of it. And it also requires a clock pulse, which is given by this capacitor 1 and resistor 1. The capacitor 1 is of the value 15 picofarad, and the resistor 1 is of 10k. So they're both providing they're working as a crystal together to provide an frequency for this ADC to work. So and I'm using two of the presets. These are called presets because we can adjust the resistance in either side. So one is for providing half the reference voltage, which is 2.5. Since my reference voltage is 5, I've given the reference voltage as 5. So this preset gives the output from this thing of 2.5 volts, and this preset over here is used to give the analog input to this ADC. So once it gets the analog input, and how we're gonna do it, it's like you do it so the resistance increases or decreases correspondingly. So it gives you the analog input through this pin, and then this ADC converts the analog into digital, and then these data pins from DB0 to DB7, they convert your data. Since it's a 8-bit analog digital converter, so it can show value from 0 to 255. So it can only show 256 values. It means it divides your analog value into 256 parts. So these are the data pins, and these I've connected my data pins to the port 1. So the port 1 of my microcontroller gets it's working as an input port, so it gets the digital values of corresponding analog values, and then I've copied the values of port 1 into port 3, which is connected to the LCD, 16x2 LCD. You can see this. So that's how my project's working. Let me simulate it. Let me start it. So here I go. I press the play button, and since it's in the middle part, so it'll show you the 128. It's the half of 256, 128. So as I keep on moving it towards the ground part, it'll become 0. You see that? It's directly connected to the ground part, right? So it becomes 0, and when I start increasing the values, so at the half it's 128, and to see the full value it's 255. So that's how an ADC works. It basically divides your analog value into 256 digital outputs. So 256 basically is the number for 8-bit analog converters. If you go for 10-bit analog converters, they'll convert your values from 0 to 1023. So that's how an ADC works. Thank you.